हॅलो.
तुम्हाला फोन लावले डिस्टर्ब तर नाही करणार खूप एका
हॅलो सर.
नाही ना ठीक
Hello. Hello sir.
Okay.
Am I audible sir?
So good morning, one and all, and a warm welcome to our today's
Hello.
guest
Hello
speaker
sir. Hello sir. Am I
and our
audible?
principal director, Dr. Krishna, on his virtual talk on first day to machine learning, organized by Department of Computer Science and Computer Application. Dear students, machine learning is the core sub-area of artificial intelligence. It makes computers get into a self-learning mode without explicit programming. When fed with the new data, these computers learn, grow, change, and develop by themselves. Machine learning has been used in several places like self-driving Google car, online recommendations engines, friend recommendations on Facebook, offer suggestions from Amazon, and in cyber fraud detection as well. The machine learning field is continuously evolving, and along with evolution comes a rise in demand and importance. There is one crucial reason why data scientists need machine learning, and that is the high volume predictions. High volume predictions that can guide better decisions and smart actions in real time without human intervention. Machine learning as a technology helps to analyze the large chunks of data, easing the task of data scientists in an automated process, and is gaining a lot of prominence and recognitions. Machine learning has changed the way of data extraction and interpretation work by involving automatic set of generic methods that have replaced traditional statistical techniques. So before we start our today's talk, now I invite our Honorable Director, Dr. Praveen Joshi sir, to say a few words. Sir.
Good morning, madam.
Good morning
Anitha,
sir.
madam, good morning.
Good morning sir. Yes, good morning sir. Am I audible sir? Sir, am I audible?
Very happy to see you here.
Thank you sir. Thank you
And
so much.
I remember the days of Kannur University when I was there to
Yes
address
sir.
the university people.
Yes sir.
I hope next time also they invite me.
Sure sir.
Today, it's a great privilege for all of us to have such a renowned scholar, Dr. Anitha, who has gone to all the width, breadth, and depth of this particular subject. She's a scholar par excellence, and a lot has been said about her by her colleagues, her friends, and other research scholars. She's a dedicated scholar, always focusing on how she can contribute to enlarge and expand the field of computer technology in the field of software as well as hardware. A lot of new things are coming up. One particular subject of cloud computing, if we take for study, there is a wide scope for all of us to invent more and more. The same about artificial intelligence. In next 5 years, we will see that most of the things are controlled by artificial intelligence, and human interference will be lesser and lesser. But at the same time, we will be moving towards greater perfection, precision, and uh, hundreds of other facilities that we at present cannot even dream of. But one question always remains to be addressed. Why the hackers? Why the antisocial elements? Why the terrorists? And why all those who want to destabilize the established system are much ahead of our scientists? How do they manage to be ahead of us when our efforts are directed with a great positivity? We are taking every precaution so that nothing wrong goes in the system. But still we find that hackers prove themselves more intelligent, more talented, and more dynamic than our technological scientists. So that question always remains to be addressed. We are trying to take all the measures to see that hacking fails. But day by day, we see that hacking prevails everywhere successfully. So it's a big challenge for the scientists, for the scholars, for the researchers as to how to stop that. In spite of so many protective measures, our system sometimes fails. So hope the scholars like Dr. Anitha will certainly work in this direction and help the nation prevent hacking to a maximum possible extent. I welcome Dr. Anitha once again,
Thank
and
you, sir.
she belongs to our group of friends, and I'm very happy that today she has kindly consented to address our faculty and students. I'm sure our students and faculty will gain a lot from your address. With this hope, once again, I thank you, madam, and I welcome you to this Prerna College of Commerce and Science. Thank you very
Thank
much.
you, sir. Thank you so much. Am I audible, sir?
Yeah, you're audible.
Yeah, thank you so much, sir. Thank you for such a wonderful word, sir. Shall I continue the session, sir, then?
Thank you, sir.
Hello?
Dear students, before starting our today's lecture, let me introduce our guest. So it is my great pleasure to introduce a passionate, self-motivated speaker, Professor Anitha Haridas. Madam is currently working as Head, Department of Computer Applications, Chinmaya Arts and Science for Women's, Kannur, Kerala. She has more than 19 years of teaching experience and 8 years experience as an business system administrator. She is MSc, MCA, MPhil and net qualified in computer science. Till date, she has published multiple business papers and also an author of one book. Now I request Anita madam to deliver the lecture. Thank you, madam.
Thank you, sir. Respected Joshi, sir, and the convener, Dr. Bharti ma'am, the program coordinator, Leela, and other faculty members, and all my dear students of Department of Computer Applications and Computer Science. Wish you all a very, very happy morning. My very sincere gratitude to the organizers of the virtual talk hosted by the Department of Computer Applications and Computer Science. Actually, when Bharati ma'am called me for a talk to the degree students of computer science and computer application, I thought of choosing a topic which is currently trending in the IT industry. As it is seen, most of the institutions are starting new generation courses nowadays. And when they start the new generation courses, most of the courses have included machine learning. Most of the courses have included machine learning as a core paper or sometimes as a complementary paper. Even when they are starting a statistic course or when they are starting a data science course or when they are starting even a mathematical course, all these courses are also having machine learning as a complementary paper. So I thought of like, why don't I just introduce this particular topic to the students? But since because of this pandemic, most of you will be online always, and you may be attending lots of sessions, webinars, and especially when you are attending a session on information technology, I think all of you might have come across this term machine learning. And it has become a normal language now, and it has become a very very normal term. And it is no more a new term or a new technology. It is becoming a normal technology which has to be adopted by everyone right from the scratch. So I thought of having machine learning as a topic for all my degree students of computer application and computer science. Without further delay, let us get into the topic. That's why I have just named this particular session your first step to machine learning. It may not be the first step to machine learning. Some of you might have attended a session on machine learning. Some of you may find it a repetition also. But even then, we are going to just talk about machine learning, and we are not going to get into the too much of technical aspects of machine learning. We are going to just experience the, I should say, the tip of the iceberg. Machine learning is a very, very vast area. We are going to just touch the tip of the iceberg. My intention for this particular topic is not to give you a detailed idea about machine learning, but I just want you students to taste uh, the idea of machine learning. So if you find it very interesting and if you find it very fascinating, you can further explore on the machine learning topic. The agenda of my session goes like this. So these are my agenda. I have just going to tell you like what is machine learning and why machine learning, how you're going to approach the machine learning, etc. And we will very briefly touch upon what are the different types of machine learning and what are the different algorithms that can be used. And remember, it is all going to give you or it is all going to get you familiarized with the terms and not the concepts. You are not going to deal with the concepts of all these algorithms. We are just going to understand like what are the different algorithms that are available in the machine learning which can be further explored by you, and some of the popular tools we can see. And I have just taken a sample Python code because Python is becoming very, very popular in all the machine learning algorithms and the coding. So I just thought of showing you the Python code, and the the a very important thing here is with maybe 10 or 15 lines of code, you can train your machine to learn something, and it will help you to predict or infer something from your data. So just you need to write only 15 lines of code or probably sometimes 20 lines of code, and you get your machine as an expert system which can predict or sometimes it can give you some kind of description. So that is the agenda behind the session. Now, these are the jargons you are coming across in the articles or in the dailies or some of the researchers or maybe your professors. all of them may be using all these jargons like data science, artificial intelligence, virtual reality, data analytics, big data, blockchain, deep learning, and of course, machine learning also. So these are the different jargons you are always coming across, and probably some of you, maybe those who are interested, might have already explored what are these topics all about. But our focus here is going to be only the machine learning in our session. Now the question is, why these jargons, right? How come all these technologies are developing in a very, very faster manner? And how all these advanced technological developments are deployed very easily in our business world? And what are the two factors that are leading to these technological advancements which are easily deployed as the system? And all these deployed software systems are really usable, and they're all very reliable, and they're all very, very innovative products also, and it is also interoperable. So no business giants are away from these jargons, right? Everybody, all the business giants are using all these concepts or all these technological developments in their business development. Now, let us see what are the two factors that are leading to these technological developments. The two very important factors, I should say. One is the large volume of data. The other one is because of the computational power and the efficient algorithms. Now, when I say these two factors, all of us know the data is multiplying like anything. Every second, every fraction of a second, a data is being generated. Imagine your WhatsApp messenger. All of you may be using it, and imagine every fraction of a second, lakhs and lakhs of messages are being shared among the users of the WhatsApp. So if you collect all these data together, the question is whether I can infer something from this particular large volume of data, which you call as the big data, which is again one of the jargons used in the emerging IT industry. So, whether this large volume of data will help you in making decisions for your business, that is what they are going to experiment on. Or you just take Google, or you take Facebook, or you take any kind of social networking sites, or any web application for that matter. All these applications or the softwares or the systems or the networking sites, everything is generating a large and huge volume of data. But when I say large volume of data, you can see here I have just given a point specifying the data can be used for business, and the data itself is used as a business also. So if you have a large volume of data which are a valid data, you can start selling this particular data. People are ready to buy the data set for their research purpose. So you collect a data set and you can start selling this particular data set. But remember, when you start selling the data set, and if you take data as a business, your business must be a very, very relevant data quality. And not only that, when you have this large volume of data, you can infer knowledge from the existing data. You have lakhs and lakhs of records of data. You derive some information from this particular data so that you can make decisions. You can make decisions to keep up with the competition, or you can help it to falling further behind. So this is the purpose of large volume of data. And not only that, whenever I say data, your big data, the data science, data analytics, storage, where do you store this data? How do you manage this large volume of data? It itself is a separate area to study. And obviously, when you have this large volume of data, you cannot store it in your local machine. So you need some kind of cloud support for storing this particular data. So this is one of the very, very important factor. Because of this particular factor, you have all these technological development. Now, the second important factor is the computational power. The power of computation is increasing like anything. I have just given a supercomputer, the latest supercomputer. What is the speed of the supercomputer here? Which is 415 petaflops, which is something similar, equivalent to 10 to the power of 15 floating point operations per second. So you can't even imagine, like within a second, a computer is capable of doing 10 power 15 floating point operations can be completed by a computer within a fraction of a second. So imagine if this is going to be the power of the computer, you can do wonders with the computer. And not only that, lots of algorithms are being developed nowadays because the algorithms have started learning on their own with the experience, and the algorithms are getting enhanced on their own. I need not reprogram it. You just feed a program, and the program is getting improved on its own with the experience. So imagine the power of the computer and the power of the efficient algorithm. So these are the two very important factors that lead you to the kind of jargons like data science or the machine learning, artificial intelligence, and whatnot. So you have large volume of data, and your computer is very, very powerful with lots of efficient algorithms. Now we are going to combine these two together. The data and the efficient algorithms are being combined together so that your machine becomes an expert system. That is what is all about the machine learning. So this is the motivation, I can say, or this may be the inspiration for introducing all these sort of technological developments. Now, all these technological developments have been deployed efficiently. And now the question is, where exactly all these advanced technologies are deployed, and how it helps the people. So these are the areas where you can apply machine learning. And most of you might have come across the Amazon. All of you might have purchased something from Amazon. So the recommendation engine, you search for the, let us say you are searching for a bridal wear, automatically the Amazon will be recommend you all the bridal accessories also, or the retargeting campaigns. Sometimes, most of the time, no, even my daughter used to do this. She will start adding all the items to the Amazon cart. Maybe we may not be purchasing it, but we will start adding it because we wish to have it in our wish list or in the cart. You just keep on adding all the items to your cart. So what happens now? Maybe you might have added an item in the cart by July, and you might have forgot it. You have not purchased it. But after 2 months, your Amazon will be reminding you, see, there is an item added in your cart. Do you want to purchase it? There is a big offer coming for that particular item. So how the Amazon is nothing but a software. How the software knows that you may be interested in the item which you have already pushed in your cart. This is machine learning. And not only that, all of you will be using your Google, and in your Google search tab, you will be typing something. Automatically, it will prompt you. Auto completion will be there, and it will prompt you whether you want to search this or whether you want to search this. So when you type something like machine learning, it will ask you like whether you want machine learning algorithms, whether you want machine learning types, or whether you want machine learning tutorial, or whether you want machine learning examples. Like that, automatically Google will help you to complete what you want to search. And the Google Translator is another example where the machine learning is applied. It is becoming better and better. Imagine 5 years back, what you have given as the source for translation, the output may not be so convincing for you. But whereas nowadays, if you give the same content to the Google translator, it will give you a better result because the machine started learning how it has to translate and it is doing the translation in a better way. And YouTube suggestions, most of you, due to the pandemic, you're all at home, and sometimes when you find a leisure time, all of you may be on YouTube, and you may be watching a particular video of your interest. Say you're watching rap music, automatically YouTube will be recommending you to watch more. Right, auto suggestions will be there, auto play will be there. If you switch on this auto suggestions and auto play, automatically it will be suggesting you, see, the next video you can watch on this rap music, maybe this one, or it may be giving you the list of all the rap music videos that are available in the YouTube. See, actually you have clicked a particular YouTube video, you have not given any data, but based on your search, which is already tagged by the YouTube, it will start searching. Okay, you are searching for rap music, so why don't I suggest other rap music videos also? So these are some of the areas where machine learning is being used. Apart from that, most of the banks, hospitals, and big giant companies are also using machine learning for their purpose. Like banks are using, suppose if you want to, um, give a loan to a customer, whether the loan will be repaid by the customer or not, that can be analyzed by the machine learning tool. So the machine learning tool can predict whether this particular customer is a reliable customer or not. That can be done by the machine learning algorithm. And not only that, obviously in the hospitals, you have lots of expert systems coming up nowadays. You can detect and diagnose diseases. So it will interact with the patient. It will ask the patient to enter all the symptoms, and you just keep on giving these symptoms. And at one particular point, the machine itself will say, probably you are having this particular disease, you can refer this particular doctor. All those kind of recommendations can also be given by your machine. And lots of marketing big giant companies are doing this marketing using the machine learning. So if they give the data, and the data, whatever data has been collected so far by the company, will be given to a machine learning algorithm, and the machine learning algorithm will be interested in giving decision to the company. Like, so this is the area which is having, say for example, for a particular item, there is a lot of demand coming from this particular area. So the company can focus on that particular area for marketing and advertisement. So that can also be given by your machine learning algorithm. And one of the latest trending machine learning one is your self-driving cars, which is the latest fascination. So which can learn by experience, and it can drive on its own without a driver. So these are some of the areas where you can see machine learning is coming into existence. Now, whatever you see as the application, not only these applications, your machine learning is now becoming a part of all the software systems or all the web applications that you come across, all the social networking sites that you come across, say your Netflix or your character recognition or your face recognition. The Facebook can easily tag, like um, uh, just by seeing the photos, it can easily tag to the photos. And Netflix, it can recommend what are the movies that you can watch. All those kind of things are being done by the machine learning. Or sometimes in your Amazon, you may be searching for a textbook, or you may be searching for a novel. And when you search a novel of a particular author, it will automatically start recommending. See, these are the following books recommended for you. Or people also search for, even when you search in the Google a particular celebrity, say you search for Amitabh Bachchan, then automatically it will recommend, like people also search for other celebrities of Amitabh Bachchan. I mean, similar to. So these are some of the areas where machine learning can be used. So all these things are just told to understand machine learning can do wonders. It can help you in making decisions. It can help you in making decisions. Now the question is, if I want to make my machine to give decisions, I'm not going to decide. The machine is going to give you some decision recommendation. How is it possible for a machine to do that? That is the next question. So we start with what exactly is machine learning, just a technical definition for machine learning. Then we will get into how machine learning can be approached as a beginner. The machine learning, you can say it is a field of study that gives computers the ability to learn on its own. That is very, very important. The program must learn on its own. A programmer should not sit in front of the machine and keep on feeding the codes. Instead, you just give a program and the program automatically starts learning by the data what is given to it. So without being programmed, without explicitly being programmed, your machine should be able to learn on its own. That is what you call as machine learning. So machine learning is obviously a field of artificial intelligence. Most of you might have already come across it is part of the or subset of artificial intelligence. When I say machine, it is automatically a software system or it is an expert system, a program which is already available there. The software system, the ability to automatically learn, and not only learning, after learning, what it has to do, it has to improve from the experience. It has to improve. That is very important. It has to enhance on its own. So when I give only 1,000 data, the performance will be varying. For the same program, I'm going to give 10,000 data, the performance will differ. To the same program, I'm going to give 1 lakh records, then automatically the performance must improve. That is what is all about the machine learning. So you make the machine to learn on its own. After learning, what it has to do, it has to improve also. It has to improve from the experience, or it has to improve from what it has learned in the experience. So that is what is all about machine learning. Now, when I say machine learning, again, I can give another description like machine learning is a process focusing on algorithm development, algorithm development that can access data and use it to learn for themselves. So, you're as a computer science student, of course, most of the big companies, giant companies are using machine learning. But as a computer science student or as a computer application student, you are going to be the contributors to the machine learning. You are not going to use the machine learning algorithm simply, but you should be able to develop some kind of machine learning algorithms. Say, I'm going to develop a new classification algorithm, or I'm going to develop a new cluster algorithm. That is what should be the contribution from your end. You are all technical students, so the non-technical people will be using your algorithm. So as a computer science student, you should be the contributors to these machine learning algorithms. So the process focusing on the algorithm development which can access data and use it to learn for themselves. Now, when I say machine learning is focusing on the algorithm, it is focusing on the data and it is focusing on the software system. So these are the three important terms that we are often using in the machine learning. I said you need an algorithm. I said you have to feed some data to the algorithm. Not only that, the software system has to learn on its own, I told, and it has to improve on its own. So the three important things that are coming in the machine learning is what kind of algorithm you are going to use, what is the data that you are going to provide, and what will be the model or what will be the software system generated in the machine learning environment. So these are the three things that comes often in the machine learning. So when I say these are the three important things, you can say machine learning is the process of training a piece of software, which I'm going to call as a model, to make useful predictions from the given data set or some useful descriptions from the given data set. This is what all about machine learning. So machine learning is nothing but you are going to train you're going to train your model or you're going to develop a model which will be useful for predicting or maybe for description. So, there is a difference between prediction and description. When I say prediction, you're going to give a new data, it is going to predict something. So, say for example, you have a new admission coming in that you want to new application coming into your college and you want to understand whether this particular student will take the admission or not. That is prediction. Or you have maybe last 10 years of students data is with you, you want to analyze something like what is the performance of my student from a particular area, what is the performance of the students those who are coming from a particular locality, then that is called as description. So your machine learning algorithms can be used for predicting the future, or it can describe something which is hidden in your large volume of data which you have collected earlier. So these are the two things that will be done by the machine learning. So your focus is going to be on how I can develop a model which can predict something or which can describe something. That is what we are going to see here. So if I want to have a model, if I want to have a machine learning model, I need two things to be combined here. One will be the large volume of data, whatever data you have collected so far. So this data can be combined with a particular algorithm, a suitable algorithm. You have to choose the particular algorithm based on the kind of data you have in your hand or based on the kind of analysis that you are going to do. I have 10 years of students record, right? Okay, very good. But you have collected all these data. But the question here is like what you are going to do with this particular data, what you want to analyze with this particular data, whether you want to analyze the performance of the students who are seeking admission in computer application, or whether you want to analyze the performance or the outcome of the students, those who have joined in the commerce course, or you want to analyze whether what is the performance of a set of students coming from a particular locality. So what analysis you want to do and what is the kind of data you are going to have, based on that you will be choosing an algorithm, and this algorithm combined with the data will be generating a machine learning model. I repeat, I have a set of data and this data is now combined with a particular algorithm, machine learning algorithm, and the output is going to be a machine learning model which we call as the software system or the expert system. Now, to this expert system, what you can do, you can provide some test data, you can provide some test data, and this will be giving you the evaluation report. It says that whether this model is, yes, it is having a precision or it is having a 100% accuracy or it can predict properly or it can give you a proper description about the data. So that kind of, you're going to test the model. You're going to test the model. You have developed a model, but you have to test whether the model is suitable for my data or not, whether it is predicting it properly or whether the prediction is having accuracy or not. So that kind of evaluation report will be given by the model when you give a test data to the model which is developed. How do you develop the model? You give the data and you have an algorithm combined together. So these two things combined together will give you a model which you call as the expert system or you call it as a software system. So once you have developed the model, you have to test the model. So what you do, you give a test data and you check whether the result generated is up to the mark or not. So that is what you call as the evaluation report. So once the evaluation report gives you a positive sign saying that the model is very good for prediction or it is very good for the description, then what you can do, you can give some new data. So your trained predictive model can predict the output for a new data, and these predictions can be used to take action in a product. For example, your system can predict whether a user likes a certain kind of video. If so, the system will start recommending the video to the user. So how do you do this? Whatever model you have already developed, you give a new data and it is going to give you the prediction or some kind of inference will be coming as the output from the machine learning model. So this is what is exactly a machine learning model. So when I say machine learning, again, you are going to combine an algorithm with the data for developing a model. Once you have developed a model, you test the model, and if the model is up to the mark, you can use the model for predicting or inferring something from for the new data. So this is what happens in the machine learning. I hope I have given some insight on what exactly is machine learning. Now, as a beginner, these are the things that you have to know and to understand how do you approach machine learning. Okay, I want to do machine learning I want to develop a machine learning algorithm, or I want to develop a machine learning model, or I want to do some research on the machine learning model, or if you feel that I want to explore machine learning, this is the approach that you have to follow. Now, in this approach, I have given 7 different steps I have given. The steps can also be combined together, and that is pictorially represented here in the combined mode also. So if you want to approach a machine learning problem, I want to develop a machine learning model, or I want to uh, develop, do you have any doubts or kind of things? Yes, Bharti ma'am, should I give you a break to collect the questions, or questions can be collected at the end? Sir, the question and answer can be done at the end.
Timing?
No, question answer. Is the
No,
there any
madam.
okay, fine. Okay then. Thank you. Thank you. So this is how we are going to approach the machine learning. This is how we are going to approach the machine learning. How do we approach it? The first thing is collecting the data or gathering the data. That is very, very important for any machine learning algorithm or any machine learning model that you want to develop. Very first step is gathering the data. So when I say gathering the data, as I told you, what kind of analysis you want to do, what exactly you want the machine to learn, or what exactly you want as an end user. So based on that, you can start collecting the data. As I told, like in your university, you want to analyze the performance of the students from a particular area. Then obviously you need to collect information regarding or relevant to that particular process. Or you want to market a product, say for example washing powder you want to market. If you want to market washing powder, now the first step is you have to collect the data, all the relevant attributes required for analyzing the marketing has to be collected as the data. So you go for data collection. So what is your analysis? Based on that, you go for collecting the data. So once you have collected the data, you will start preparing the data. What do you mean by preparing the data? When you collect the data, sometimes you will be having noisy data, or you may be having some kind of missing data, or data may be in very different forms. Like say, for example, when you collect the data, probably the gender of person may be represented as female and male in a particular data set, whereas the same may be represented as M and F in another data set, or sometimes in another data set the same gender may be represented as a girl as a boy. So the same information is now represented in three different ways. So you have to collaborate them together, and you have to transform all these data into a uniform form, uniform format. That is what you call as preparing the data. So you collect the data and then you transform the data in such a way that you are having all consistent data for the analysis. So once you have collected the data, you go for selecting a suitable model for analysis. So this is where you are going to select a particular machine learning algorithm. You have to select a particular machine learning algorithm, whether you want to do the classification process, or whether you want to do the clustering process, or you're going to do the grouping, or you want to do prediction, you want to do the description. So based on that, you are going to select a particular model here. When I say model here, the algorithm, what algorithm you are going to use to analyze that particular data will be chosen here. So once you have chosen the algorithm, so now at this particular stage, you are ready with your algorithm, you are ready with your data. Your algorithm is ready, your data is also ready. Then what you can do, you can go for training the model. You can go for training the model. So your data is ready. Your data is now transformed into consistent format. Now this data along with the algorithm, whatever different types of algorithms are there, any one of the algorithm which is suitable for your analysis can be chosen, and this algorithm combined together will be given for training the model. So you now train the model. How do you train the model? The data and the algorithm will be given to generate a particular model. You will be generating the model here. So once you have generated the model, you go for testing or evaluating the model. You go for testing or evaluating the model. Then you can go for fine tuning. So once the model is tested, if you say the precision of the model is not high precision, then you can again change the attributes of the data. Again, you can train the model. You can keep on modifying the parameters or adding the attributes, or sometimes you can even exclude some attributes or add some attributes. Then you can start training the model again and again until you get the correct precision. So once you get the precision, you go for running the model. What for you're running? You want to predict or you want to infer something. So this is how you will be approaching the machine learning, by gathering the data, prepare the data, and select a particular algorithm. Then you go for train the machine. How do you train the machine? You give the algorithm as the input, you give the data as the input. Data and algorithm you're going to give as the input, and what will be the output? It is going to give you a software system. But what we do in our traditional programming, we give program, we give the data, and once you give the program and data, output will be generated or answers will be generated. That is our traditional programming model. You input data, you feed the data, and the second one that you're going to feed the machine will be the program and the data will be fed into the machine, and the machine is going to generate the output or the answers. But what we do in the machine learning, the reverse we are going to do in the machine learning. I'm going to give the data and I'm going to give some set of rules which you call as the algorithm. The algorithm is nothing but some set of conditions or some set of rules that you are going to specify. So these rules and the data will be given to the machine, And what will be generated by the machine? The program or the model, you call it as, or you call it as the expert system, or you call it as the software system, which is capable of predicting or capable of describing. So that is going to be the output generated by the machine learning. So that is the basic difference between the machine learning programming and your traditional programming. In your normal Java or your what do you call C++ C++ programming, what you have done in your lab session, you feed a program and you give the input, it is going to generate the output. But here on the other hand, in the machine learning, what we are going to do, we give the data and we are going to give the rules for generating the output also. Then your machine is going to give program as the output. That is the basic difference between the machine learning and your traditional learning. So what I have done, I have just taken a sample data. So this is how you have to collect the data. The first step I told you is gathering the data and preparing the data. So what you have to do, you have to gather data, something like this. Suppose, say for example, you want to understand whether a customer buys a computer or not. That is the problem statement you're going to have, whether a customer buys a computer or not in a computer shop, let me say. If this is the case, these are the information that you are going to collect. All these data are collected. Say the age of the customer, income of the customer, whether the customer is a student or not, or whether what is the credit rating of that particular customer. These are the 4 attributes that you are going to collect to understand whether the customer buys a computer or not. So this kind of data you have already collected, and all these data is already giving you an information saying that this particular customer will buy a computer, or this particular customer may not buy a computer. This data is already in your hand. So once you have this data, what you have to do, you have to select a particular model. So what kind of model you can select here? Because I want to predict whether a customer buys a computer or not. So a suitable model can be a regression model. You call it as a regression algorithm. I can choose a regression algorithm which can predict whether a customer buys a computer or not. Then what you can do, using this regression algorithm and the data what you have collected, this is the data you have collected, and the algorithm I'm going to choose will be the regression algorithm. Then I'm going to train the machine. When you train the machine, you can use any of the tools that are available, or you can use a particular program. Let's say a Python code can also be used to train the model. So once you have trained the model, depending on the data and the kind of analysis, you can fine tune the parameters. After fine tuning the parameters, you run the model to predict. So what you are going to do to predict, you give a new data, a new customer information. What is the age of the customer? What is the credit rating of that particular customer? Whether the customer is a student or not? What is the income of that particular customer? All these data you are going to feed now, so that you will be getting the model predicted saying whether this customer buys a computer or not. So that is what happens here in the machine learning. So as a beginner, these are the things that you have to know. What are the different types of machine learning? What are the different algorithms available? What are the popular tools that are available, and which are the preferred programming languages that can be used for developing machine learning programs? So these are the things as a beginner you must know. So let us very quickly look what are the different types of machine learning. Sometimes most of you might have come across all these terms if you have attended other machine learning sessions. So the different types goes like this. You have supervised machine learning, you have unsupervised learning, then the third one is reinforcement learning. So supervised learning is nothing but your data is already labeled. Say for example, I have set of dogs here, I have set of cats here. So I take each image and I'm going to label this as dog, and this image is also labeled as dog, and this is also labeled as dog, and this is also labeled as dog. The same way, all these 4 images are labeled as cats. So it is already labeled. It is already having the answer. Now you're going to give this data to the machine, So the machine can understand if these are the features of the image, I can call it as dog. If these are the features of the image, I can call it as a cat. Because you have already told the machine that if a particular image is having these features, you are going to call it as a dog. That is the rule you have already given to the machine. So the machine is now going to learn from these rules, which is already labeled. You are already teaching the machine, saying that if the image is having these attributes, you call it as a dog, or if the image is having these attributes, you call it as a cat. No more excuses. So what the machine will do? Yes, it is going to learn, and when it sees a new image, it is going to check whether the new image is having the attributes of these images, or whether the new image is having the attributes of these images. Accordingly, it will say it is a dog or a cat. That is what you call as supervised learning. Whereas in the unsupervised learning, what we do, we are not going to give the label. I'm not going to say this is a dog, this is a cat. I just give all the images, right? You just give all the images in a scattered manner. Now the machine has to find some pattern. It has to discover some pattern on its own. Whatever patterns are hidden already, the machine has to discover the pattern on its own. Say, for example, I have collection of data given here as samples. From the samples, it has to find out the nearest similarities of each and every object. Then it is going to group them together. So you are giving the data as a scattered data without any label. But what it has done, it has discovered some patterns, like it is having potatoes of this particular color and the potatoes of this particular color, and these are onions which is having this particular color. Like that, it has discovered the pattern on its own, and it is going to group them together, which can be a clustering process. That is what you call as unsupervised learning. Whereas the reinforcement learning is a different learning, where you are not going to give any labels and you just give some data, and the computer will say that, suppose, say for example, you are going to give a data, let me say you are going to give an image of the apple, and you will ask the computer to predict what is the fruit. The computer says it is a mango. When it says mango, you say, no, it is not mango, it is wrong. You just say it is wrong, and the feedback is given to the computer. Again, the computer is going to predict, and it says it's a grape. And again, you say it is a wrong answer. Again, the computer will predict, and it says, is it an apple? Now you say, yes, it is an apple. That is the correct answer. So when it gets the feedback of correct answer, what it is going to do, it is going to learn on its own. So the next time when you show the apple image, it can easily predict it is going to be an apple. So what has happened now? It is going to learn from the feedback given by the output. Whatever program you are going to have, it gives the feedback, which you call as the reward or penalty. The feedback can be a reward or a penalty. So to maximize the rewards, the algorithm will be trying to learn. That is what the reinforcement learning is. So in the supervised learning, you are going to already give the answer to the computer, and the computer will learn from that. Whereas in the unsupervised learning, you don't give any answer, you don't label anything. The system has to learn on its own, it has to discover the patterns on its own, then it has to group it. And in the reinforcement learning, you just give the data and you ask the machine to predict, and the machine gives you the answer. You give the feedback as a reward or as a penalty. So if it is a reward, it learns, and if it is a penalty, it corrects the output that is being generated. So these are the three kinds of learning you will have in the machine learning. And these are the different algorithms you have. You can have classification algorithms, regression algorithms, decision tree, random forest, clustering algorithms, k-mean and k-nearest neighbor. These are different algorithms available. You can further explore on. So what is your requirement? What is your analysis? Based on that, you can select any one of the algorithm for your process. So after the algorithms, now we have understood the different types of machine learning. Different algorithms are also available. You have lots of tools to help you in developing the machine learning models. These are the different tools that you come across. Most of you might have already gone through TensorFlow, Collab. You might have already used, and Rapid Miner. It's a very interesting tool where you will get a very good graphical user interface. So you can have how the model is being designed and developed can be pictorially represented using the Rapid Miner. And Amazon and Google ML, these are all cloud-based tools that are available. Veka is another data mining tool which is available that helps in developing machine learning models. So these are different tools that are available. You can explore all these tools, and any one of the tool you can use to develop the machine learning model. Now, this is going to be the last portion of my presentation. I have just collected a data here. I have collected a data. And data is all about the gender of a person, age of a person, and salary of the person. These are the three data I have collected for each and every individual. And I just want to predict whether a customer will purchase a bike or not. So this is my earlier data. This is my earlier data. This data set shows whether the customer purchased a bike or not. So 0 says the customer did not purchase a bike. 1 says the customer purchased a bike. So this is the yes or no case, which will be called as the answers for my prediction. And these are the data which I am already having. So data set I have already collected. Now, the next thing is I have to choose an algorithm. You can choose an algorithm for prediction. So generally for prediction, you can have a regression model. You can have a SVM classifier algorithm. These are different algorithms available. What I have done, I have chosen a SVM classifier algorithm to develop a model which will say whether a customer will buy a bike or not. And I have to train and test the model. That is the next step. For training and testing the model, I have to use some kind of tools. So what I have done, I have used a Python code for training and testing the model. And the same code is also used for predicting the model. Predicting the new data. So this is how I'm going to do. And you can see the interesting part here. This is going to be the sample code. So observe here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So just by having these 11 lines of Python code, I can develop a model, a predictive model, which can whether a customer will purchase a bike or not. As simple as that. So just this Python code, the first step, which is in the red color, this is the first step I'm going to use to collect the data. And this is the data I have collected. I have stored the data in a CSV format, and I'm going to collect the data for my processing. Yes, my data is now ready just by having this particular statement in the Python. Then what I have to do, I have to prepare the data. I'm going to split the data here as a training data as well as the testing data. All those terms I have not discussed here. I just want you students to understand like what exactly is machine learning, and all those terms, training data, testing data, all those things you can further explore in your if you are fascinated with the machine learning. So these are the two statements I need to write to prepare my data for the model development. And I have three statements here which are using the SVM classifier. And just by having these three statements in the Python code, you are training the machine. Your machine is ready now with that particular model. So the model will be developed here, and the model is what you call as Y predict model. YPRED is the model which you have developed. So once you have developed the model, you're going to test the model. You're going to invoke the predict method, and the predict method will be testing whether the model is suitable or not, or whether it is having high precision or not. So if you are convinced and if you feel that it is a high precision data, model, you can go for predicting the data, predicting the new data. So you have a new data here collected, and you just use your predict method by passing the new data, and it will be displaying whether the customer will purchase the data, purchase the bike or not. So what are the three information you will give? You input the age of a customer, salary of the customer, and gender of the customer. Just by giving this data, the machine is now going to predict whether this particular customer will purchase a bike or not. So this is what is all about the Python, and you can see here how simple it is. All these algorithms are already available as packages or as modules in your Python. So you just download or import those modules in your program, and you can use all the functions and that are available in the modules. So just by running those functions, your program is ready and your model will be ready for predicting or describing. So this is what you have to understand under machine learning. What we have covered so far is just tip of the iceberg, just to get a feel of what exactly is machine learning. I have just touched upon, and I think I'm done with. And also I just want to show you one more slide here. So this slide shows you, I was talking about evaluating the model. So if you have these set of codes in your Python, it will give you what is the percentage of accuracy. So once you have designed the model, you can check the accuracy of the model, and if it is 100%, and if it is above 70 percentage accuracy, your model can be called as a better model. So if the accuracy is above 70 percentage, you can say, yes, my model is of course good model. You can use it for prediction or for the description. That is also possible. So you can have the evaluation also being done in the Python code itself. So this is what I want to share. And if you have any doubts or if you want to interact with me, I think I'm ready to take the questions. With that, now it's 11:10. I have taken 10 more minutes actually. Yes, if you have any doubts or you want to interact, you can post your queries or you can ask questions. No issues. Once again, I thank all the organizers for giving me an opportunity to share my knowledge with the students. I have not covered the entire machine learning. I have just touched upon maybe after the session, you can just feel that you are familiarized with some of the terms that are using in the machine learning concepts. That's it. So that's my motivation here, and that is my intention also, just to get you familiarized with some of the terms that are coming under machine learning. Thank you so much. Sir, I'm done with the presentation.
Thank you, ma'am.
Yeah, thank you, ma'am.
It's my privilege to have been asked to propose a vote of thanks on this memorable webinar. I, Vidya Mulmule, on behalf of Prerna College of Commerce, Department of Computer Science, welcome you all. First and foremost, I thank our honorable speaker, Professor Anitha Haridas Madam, HOD of Computer Application Department in Chinmaya Arts and Science College, Kannur, Kerala. who in spite of her busy schedule has found time to grace this webinar and immensely enlighten all our students on the topic first step to machine learning. Madam told us how machine learning is useful and areas where machine learning using nowadays. It was wonderful experience listening to her on this occasion. We express our profound sense of thankfulness of her kind address. Thank you so much, ma'am. I would like to express our sincere thanks to our Honorable President of Prerna Seva Mandal, Professor R.C. Gullane sir, Secretary of Prerna Seva Mandal, Dr. S.C. Gullane sir, Director of Prerna College of Commerce, Dr. Praveen Joshi sir, and officiating principal, Dr. Bharti Deshmukh madam, for continuous guidance, motivation, and their support. I thank all dear students for their overwhelming response and feedback. At last, I thank all for making this webinar a resounding success. Thank you. Have a nice day.
Thank you, ma'am. I once again thank the organizers for giving me an opportunity to present a session here.
Thank you, ma'am.
Thank
Thank
you. All
you.
the very best to the college.
Thank
And
you.
I also wish the best for all the students of Department of Computer Applications and Computer Science. Thank you.
Thank you.
Thank you.